Okay, we are going to be looking at unit vectors. Now, a unit vector is a completely normal vector. It just has this one special property. It has magnitude 1. So we remember what magnitude means. Magnitude is the length of that vector. So a vector is a journey. That means it takes us on one step in whichever direction this thing is facing. We normally put them in little hats to show that they are special unit vectors. So let's have a look at these two examples. Here I have vector v. Components 2, 1, minus 2. It's not a unit vector. If we look at the length of v, we've got root 2 squared plus 1 squared plus minus 2 squared. It's 3 steps long. But this one, on the other hand, root 2 thirds squared plus 1 third squared plus minus 2 thirds squared is root 1. Square root of 1 is 1. So this is a unit vector. Hooray! Now we can take any vector and turn it into a unit vector by dividing it by its magnitude, by its own length. This makes sense. Anything divided by itself is 1. 10 divided by 10 is 1. 100 divided by 100 is 1. So if I have any vector v, I can make that into a unit vector by dividing by its magnitude. It's always parallel to v. It has the same ratio of components. The only difference is it just has that one step. So we're going to use that, and we're going to find a unit vector in the direction of 6, 0, minus 4. So we're going to recall that. My unit vector in this direction is going to be my vector divided by the magnitude of my vector. So that's going to be, I'm going to change this into component form, 6i plus 0j minus 4k divided by the magnitude of v. So let's find that. So the magnitude of v is going to be square root 6 squared plus minus 4 squared, which is square root 36 plus 16. Which is 40 plus 12 is root 52. So it's going to be over root 52. So then I have v equals 6 over root 52i minus 4 over root 52k. And I could probably put that into a calculator and make that slightly neater, but for the purposes of this we won't bother. Now we could be asked some interesting algebra question, well, moderately interesting algebra question. So find the two possible values of a so that 2ai plus aj plus 2ak is a unit vector. Have a think, how would you solve this? Well, if it's a unit vector, I know that the length is 1. So I know the magnitude of this vector is 1, so I know 2a squared plus a squared plus 2a squared equals 1. So if I square both sides, I'm just left with 2a squared plus a squared plus 2a squared is 1. Let's just perform those operations to simplify this down a bit. So that becomes 4a squared plus a squared plus 4a squared equals 1. And now we can solve for those two values. So I have 5a squared equals 1, a squared equals 1/5. So therefore a equals either positive or negative root 1/5. So those are my two values. Positive root 5 or negative root 5. And that is basically what a unit vector is. It's a little vector with length 1.